I'm Anil Kumar. Welcome to my series on functions. I've taken few test questions on application of functions. So from question number 9 to 16 are application and thinking question. Let us see how to solve them one by one. Question number 9. The formula for converting a temperature in degrees Fahrenheit into degrees Celsius is C equals to 5 over 9 F minus 32. Write the formula in function notation, write the inverse of the function, convert 9 degrees Celsius into degrees Fahrenheit. So we are given this formula. Let's do part A first. We are given the formula C equals to 5 over 9 times F minus 32, where C is degrees Celsius and F is degrees Fahrenheit. Now when we are writing in function notation, we know C is a function of F, right? So we'll write this as C as a function of F. And that is equal to 5 over 9 F minus 32, right? So that becomes the function notation. You could also use X and Y, but this is a preferred way of writing, right? So that is part A for us. Now let's do part B, which is write the inverse of the function. So to write inverse, we will do swap, right? So first step is swap and then solve. So these are the two steps involved. So think like this now. Let me do it two ways I will show you. We'll treat this as y, this as x to write the function itself. So we'll say this is y equals to 5 over 9 x minus 32, correct? Now, first step is to swap. So we say x equals to 5 over 9 y minus 32, correct? We have to isolate y. So we'll do 9 over 5x equals to y minus 32. And from here, we get what y is. And we say y equals to, bringing 32 to this side, 9 over 5x plus 32. Clear? Okay. So let me rewrite the solution on the right side. Now we have to write this as an inverse function, right? So y, now what we have done here is we have written Fahrenheit in terms of Celsius. So we'll write this answer as Fahrenheit in terms of Celsius is basically equal to 9 over 5c plus 32. So that becomes the solution for part B. Do you see that idea? So that is what we did, correct? Now alternate method will be also, let me also talk about alternate method here. To get the inverse, we are given C equals to 5 over 9 F minus 32, right? Inverse means what? Inverse means to swap, right? So we'll just do, we need to find what F is in terms of C. So we'll just cross multiply. We get F minus 32. And that results into the answer, which is F is equals to 9 over 5C plus 32. Is that clear to you? So if the question is to find the inverse of the function, whenever the application questions are there is no need to swap and do all these steps. You could do direct also, right? So write the inverse of the function. So you could also write this. This is in function notation and that is without function notation. However, both are correct, right? So you could write either one of them, correct? Now let's do part C. However, this is preferred, okay, because you're learning about functions and function notation. So let's do part C now, which is convert 9 degrees Celsius into Fahrenheit. So we'll just replace this with 9, right? So F is equals to 9 over 5 times 9 plus 32, right? Which is 81 over 5 plus 32, okay? You can use calculator to calculate this. We have 81 divided by 5 plus 32 equals to, in decimals, 48.2. Clear? So that is how you could do it. if the calculator is not allowed, then this is not a difficult calculation at all. Perfect. But I hope you have understood how to find the inverse when we are working on application question. This is a preferred method, but this can be done as an alternate method. Well, here is another question based on the same concept. Question number 10. You start up a business selling muffins. You can make the muffins for 30 cents each. Advertising will cost an additional $18. Write an equation showing cost of making and selling M muffins. Right, so cost of making and selling M muffins. So that is the cost of making and selling M muffins. So M becomes your independent variable. And this is your recurring cost with 0.30 times M plus fixed cost of 18. Is that clear to you? So that is how you can actually write down your equation. Now you need to find the inverse of this function, right? So for inverse, we could do a direct method and we could do swap and solve, correct? So we could do either. So if I do direct method, I'm isolating M. Basically, when I do direct method, that means isolate M in this case, correct? So what we get here is the cost C minus 18 is equals to 0.30 M, and so M is equals to cost of the muffin minus 18 over 0.30, correct? So when you do the inverse, basically you have found that the number of muffins for the amount C which you pay could be written as cost minus 18 over 0.30 as your answer, correct? So if you do direct method, those will be your steps. And if you are doing indirect method, right, so in that case what we do here is we write the equation in y and x form. So y equals to 0.30 x plus 18. We swap x equals to 0.30 y plus 18, and then we solve. So we get x minus 18, and then we'll divide by 0.30 to get the value of y. And then we'll finally, y is this number of muffins. So we got number of muffins in terms of the cost, right? And this becomes the cost now. So cost minus 18 over 0.30. Do you see that? So both are correct methods. You could adopt any one of them. What you are being taught is this particular method, correct? So that is preferred. Right, this is okay. So these are the two methods which you could adopt, right? Let's move on and take up question number 11, which is consider the function f of x equals to 5 times x minus 4 plus 9. Find f of 2b. So f of 2b, you have to replace x with 2b. So we get 5 times 2b minus 4 plus 9. So just expand. So it is 10b minus 20 plus 9, or which is 10b, and that is minus 11, right? So we get f of 2b as equal to 10b minus 11. The next question, question number 12, is consider the function f of x equals to 1 over 3x and g of x as 1 over x squared. Determine f of 112 minus g of 15. Okay, so let's first find what is f of 1 over 12. So in this formula, let's substitute 1 over 12. So we have 1 over 3 times 1 over 12, right? So which is, you could write 12 over 3 here, perfect, which is 4. Now let's also find what is g of 1 over 5. So g of 1 over 5 is 1 over x squared, so 1 over 5 squared, correct? So which is, you take this up, right? So we have 5 squared, which is 25, correct? What do we need to figure out? We need to find what is f of 1 over 12 minus g of 1 over 5. So we'll substitute these values. We have got 4 minus 25, and that is equals to minus 21. So that is our answer. Is that clear? So these are the steps involved to solve this type of question. Question number 13 is a very interesting question, and normally it's difficult to answer. Question number 13 is, given f of x equals to k times 4 plus x, find the value of f if f inverse minus 3 equals to minus 5. So this inverse function means what? On the inverse, we have a point minus 3, minus 5, correct? So this is a point on inverse. Let's call this as A, right? So A, a point on inverse function. So that is basically a point on inverse. So what will be this point on the function? We need to swap, right? So it becomes minus 5, minus 3. Does it make sense to you? So you need to swap to get a point on the function, right? So we are moving from left to right in this case to solve, right? So we found that the point on the inverse, so we're doing the reverse, right, is minus 3, 4. So the original point on the function, origin, is minus 5 originally, this. So that means if I substitute minus 5 for x, I should get minus 3. So basically it means minus 3 is equal to, substitute minus 5 for x, k times 4 plus minus 5. Does it make sense to you? So simple. So when you're given a point, just flip it and get it here. So we get minus 3 equals 2. So this is k times, that is minus 1, right? So minus 3 divided by minus 1 is k, which is equal to 3. So our answer is k equals to 3. Is that clear to you? So that is how we are going to answer this question. I hope this concept is absolutely clear, right? So we had a function and we have its inverse. We are given point on the inverse function, which is minus 3, minus 5. Flip it to get the point on the function, minus 5, minus 3. So at minus 3, we should get a value. At minus 5, we should get a value, which is minus 3. So we substitute minus 3 for f of x and minus 5 for x, and in a minute, we can get the answer. That is how you have to do it. You don't really have to work on the inverse, right? Okay, so let's move on now to transformation. So we'll have a couple of questions based on transformation of functions. Question number 14. Describe the following transformation from the parent function. F of x equals to 5 minus 2 over minus half x plus 3. So parent function is what here? Parent function here is y equals to 1 over x. So with respect to that, we have to describe the transformations, correct? So let me just rewrite this function here. So we have f of x equals to, I'll prefer to write this first, which is minus 2. I'll associate minus with the numerator. And this is minus half x plus 3. And we have plus 5 here. Is that clear to you? So now let's write down all the transformations, right? Okay. So to begin with, this minus is a reflection on x-axis, right? So that is a reflection on x-axis. Now this too is vertical stretch. By a factor of 2. Now, here, this minus is horizontal, right? So it's reflection on y-axis. Half means horizontal stretch. By a factor of 1 over half, which is 2. Is that clear? And then plus 3 means horizontally, you're moving 3 units left. So let me combine translations together. So now we have 3 units. This is left, wrong. So what we have to do here is that we have to factor minus half first and then rewrite, right? So that'd be wrong, okay? So what we need to do here is we will rewrite this minus 2 over. We'll take minus half common, right? And then we get x, and this goes in, so we get minus, and multiply by 3, we get 6, right? And then plus 5. Do you see that part, correct? So it is not 3 units left. Now you can clearly see that it is 6 units right. So it is 6 units right. Do you see that correction? Now that is kind of very important. If you do not factor, you'll end up in wrong answer at this place. 6 units right and 5 units up. Is that clear to you? So let me mark this. This is very, very important. And many times we have seen students making this mistake. Correct? So that is kind of important. So note, it is 6 units right and 5 units up. Perfect. Let's take another example based on transformations. Question 15. The function f of x is absolute x. Now this function is vertically stretched by a factor of 5, is stretched horizontally by a factor of 4, has a reflection in the x-axis. Translated 3 units to the right, write the equation of the transformed function. So let's go one by one on this. So we have this function f of x equals to, so absolute value, vertically stretched by a factor of 5. So we get 5 outside, right? Horizontally stretched by a factor of 4. So within this absolute function, when we say horizontally stretched by a factor of 4, it is 1 over 4, right? And then write brackets, right? For this x. Has a reflection on the x-axis. So when you are reflecting it on the x-axis, that means it is vertically getting reflected. So this gets minus. So this is a reflection on the x-axis. Translated 3 units right, so minus 3. That is it. So that becomes your function. Is that clear to you? So this minus here is reflection in the x-axis. Is that clear to you? Correct? So, and rest of the things, let us associate them. So we have stretched horizontally by a factor of 4, which is this. Is that okay? And then we have a translation of 3 units to the right, which is this. And of course, the first thing which we did was vertically stretched by a factor of 5. Okay, so which is this. Clear? So that is how you're going to write down a transform function. Now here we are at the last question. We need to sketch the graph of the function minus 2 square root of minus 4x plus 8 plus 3. Find domain range. I'd like you to pause the video, answer this question, and then look into my suggestions. There is a very interesting question on graphing, which I've taken from this test paper right there, right? So many times we find students making some mistakes. So I thought I'll discuss this with you, and let's see how to do it correctly. Question number 16 is sketch the graph of the function minus 2 square root of minus 4x plus 8 plus 3. Find domain and range. So there are two parts to this. Whenever you're given a function in this form, first thing is to rewrite this. So we'll write minus 2, okay, square root of minus 4. That has to be factored, right? So you get x, and that you divide 8 by minus 4. So you get minus 2 plus 3, correct? So that becomes your base. So as you can see, your function is actually reflected on both x and y axis, correct? So roughly speaking, if you're talking about just sharing with you, roughly speaking, the graph of the original function will be square root function, right? This is your square root function. Now what is happening here is this graph is being reflected, right, like this, correct? And then, so that is because of this, and then because of this minus, it gets reflected kind of like this, correct? And then we will get into the final graph with two translations. -2 means right and this means up, right? So basically we are expecting a graph which should be kind of like this. So whenever you read a particular equation to be graphed, make an idea of what you are getting into, right? So that is what we are looking into as our final result. Okay. Now there are many ways to do it. What we could do here is we can have a mapping diagram. So if your coordinate points are x and y, then we can map them like x values will be now divided by -4. So we have minus x over 4. We'll add 2 to them, correct. As far as the y values are concerned, they will be multiplied by -2 and then we'll add 3 to them, correct. So that becomes your mapping diagram. Okay, so with this, we'll actually make table of values and we'll map some of our values. So on the original function, which is, let us say, square root of x, and here we have this transformed function which is -2. I'll write it in this form, -4 x minus 2 plus 3. Okay, so we'll calculate some values. So let us take origin, because in this it is always from 0, 0. So if I put 0 here, we get 2, and there we get 3. So we have a point 2, 3. Then we have 1, 1. So if I write 1 here, so we get 2 minus 1 over 4, right? So for 1, we get 2 minus 1 over 4. So we have a point 2 minus 1 over 4 is 1, 3 by 4. And here, if I substitute 1, so we get -2 plus 3, which is +1, correct? Okay, so let's take a point which is 4 and square root of 4 is 2. So if I substitute 4, we get -1 plus 2, so we get 1 here. And 2 minus 4 plus 3 is -1, correct? So we get these points. So these are good enough points to begin with. So let me just draw the axis and then we'll sketch the graph. So we are looking for this kind of a graph. So let me just draw axis kind of like this. Okay. So the very first point which we could see here is 2, 3, right? So at 2, we have a point 3, that is 1. And then we have 1 minus 1. So at 1, we get -1. And then we have 1, 3 by 4, 1. So at 1, it is slightly less, kind of like this. Do you see that part, right? So these are the points which we get. Now, you could actually, from the function also, write this as 0 and then figure out a point, right? So if I write, I'm just substituting 0 here. So if I write x as 0, in that case, we get, so we have -2 square root of 8 plus 3, right? So definitely a big negative number. So what we will do here, since this is an approximate number, so let's get an idea of this number. It is basically 3 minus 2 square root 8, right? And that is equal to, in decimals, minus 2.65. Okay. So we just got an idea about this. So minus 2.65, somewhere here, right? So this is not critical, not so important. But I feel is good to take. So that's a y-intercept. So consider this point, and now we can actually draw this graph here. So that becomes your final solution for the graph of this function, right? So I actually prefer to find this y-intercept also. Is that clear to you? So that is how we are going to do. Now let's write down its domain and range. So clearly the domain is, we can write x belongs to real numbers, where x is less than equal to 2, right? This point is 2 and this is 3. So where x is less than equal to 2. And as far as the range is concerned, range is y belongs to real numbers, where y is less than equal to 3. So y is less than equal to 3. Is that clear to you? So that is how we can get domain and range for this particular function. So I hope this concept is absolutely clear. So it's a good idea to use the points as we did. You may or may not look into this point. Just sketch with these 3 points. That should be okay. You'll definitely get correct domain and range. But it is a preferred thing to always find y-intercept. It's not difficult to calculate. So with that, we come to an end to important test question on functions, Unit 1, MCR3U. I hope it really helps you to understand the topic better. Feel free to write your comments, share your views, and if you like and subscribe to my videos, it'd be great. Thanks for your time and all the best.